Here is an example of integration by partial fractions, where in the denominator here, one of our factors is an irreducible quadratic, x squared plus 9. So there's nothing we can do with that to break it up anymore. So we have to break up our fraction like this. A over x plus 3 plus something over x squared plus 9. And this thing on top might have an x in it, so we'll have to say b times x plus c. And then we multiply this out on the right side so we can compare the terms. So the numerator on the right must be equal to the numerator on the left there. So when I multiply out that numerator on the right and group up all the terms, I get the following equation. And with that I can compare the terms for that numerator on the left with the terms on the numerator on the right. So first I look at the powers of x squared, and I get a plus b is equal to 1, because I have 1x squared on the left and a plus b times x squared on the right. Then powers of x, I have 3b plus c, and I also have 1 on the left. And finally, for the constant term, I have 9a plus 3c is equal to 30. So you can solve this whatever way you want to get a, b and c. I have 3 equations, 3 variables, so I can solve it. What I'll do is this. I'll take that first equation and I'll say b must be equal to 1 minus a. Then I'll substitute that in to the second equation. So that means that 3 times 1 minus a plus c is equal to 1. Or 3 minus 3a plus c is equal to 1. Or minus 3a plus c is equal to minus 2. So now between the green equation and that blue equation, I have 2 equations with a and c that I can solve. So what I'll do is I'll take that blue equation now and I'll say that c is equal to 3a minus 2. And I'll substitute that back into the green equation to get 9a plus 3 times 3a minus 2 equals 30. And now I can solve that for a. And I get a equal to 2, which I can then substitute back in here to get c. So I have c is equal to 6 minus 2 is equal to 4. And I can then substitute that back into my red equation to get that b is equal to 1 minus 2 is equal to minus 1. So now I have a, b and c, and I can rewrite my integral. So there's my broken up integral. So I can put in my a, b and c now to get the following. And what I can then do is break this up into 3 separate integrals. So that term on the right can be split up as well. Now the first and third integrals there are relatively straightforward, but I'll do each of them one at a time now. So I'll start off with the first one. The integral of 2 over x plus 3 dx is equal to, well, that 2 stays in front, and the integral of 1 over x is log x. The integral of 1 over x plus 3 is just the log absolute value x plus 3. So there's my first one. The second one, the integral of minus x over x squared plus 9 dx. This will require a substitution. U equal to x squared plus 9. That gives me du dx is equal to 2x, or dx is going to be equal to 1 over 2x du. So when I substitute back in here, I get minus x over u, and dx is 1 over 2x du. So you can see there my x's are going to cancel. So what I'm left with there is the integral of, well, minus a half times the integral of 1 over u du, which I can do. That's minus a half log absolute value of u. And when I put back in my u, I get minus a half log absolute value of x squared plus 9. The last term is the integral of 4 over x squared plus 9. So that's 4 times the integral of 1 over x squared plus 3 squared dx. So this is an integral that we have a formula for. And that formula gives us the following. That 4 stays in front, and I get 1 over 3 times inverse tan of x over 3. So now, with all that, I can go back and put the 3 together to get my answer. Not forgetting that I really should have had constants of integration for all of those terms, but I left them out because at the end they're all going to be combined into one. So I'll say plus c there at the end, and we're done.